Good morning, over at LC Middle School students. We have lesson 10 for you today, interpreting graphs of proportional relationships. And we're actually not going to start on page 39, we're actually going to jump over to page 41 first for our first example today. All right, it says the graph below shows the amount of time a person can shower with a certain amount of water. And here on the bottom of our graph we have how many gallons of water gets used and how many minutes are taken up. Now, before I even look at my graph, I see it goes from 0 to 20. So these little intervals here, you have to kind of sometimes check, I guess. Sometimes they go by 2s or by 4s, or in this case by 5. So 5, 10, 15, and then 20. Now going up the side here, it goes 1, 2, 3, 4, 5. So those will go up by one at a time. All right. Can you determine by looking at the graph whether the length of the shower is proportional to the number of gallons of water? Explain how you know. Well, yes, we do know this is a proportional relationship because that line is straight and it does extend through the origin. So that's good. Now, B, how long can a person shower with 15 gallons of water? How long can they shower with 60 gallons of water? Well, we look at our choices up here. 15 gallons of water. All right, so here's my gallons and my x-axis. And right here is my first dot, and it looks like it lines up with the 5 minutes. So 15 gallons means 5 minutes. Now I use my XY coordinates there. X was 15 and Y was 5. And then 60 minutes, I'd go up to the same thing and let's see, go to your 60, or sorry, that'd be your 60 gallons of water. And then you go up and you find your 20 minutes worth of time. So 60 gallons will get you 20 minutes. So the X coordinate was 60 and the Y was 20. What are the coordinates of point A? Well, look back up here, we find point A, and since these go by 5s across the bottom, 25, 30, and the 30 climbs all the way up to the 10-minute mark. So 30, 10. So what's that mean? A 10-minute shower uses 30 gallons of water. Can you identify the unit rate? Yes, you could take any point, that 15, 5, or 30, 10, etc., and divide your y's by x's. We've always divided y values by x values. So we take, like, for example, 10 divided by 30. 10 divided by 30 is 0.3 repeating, or what we call 1/3 of a minute per gallon there. Now, that's kind of backwards from how we usually would do this, but we're just going with how they set it up. So in 1/3 of a minute, you're going to use 1 gallon of water. All right. Now, we're still asking a couple questions based off this. One more. For E, it says, write the equation to represent the relationship between the number of gallons of water used and the length of the shower. Now, whenever they tell us to write an equation, we arrange that y equals kx format. We just found that constant of proportionality, or our unit rate, and it was going to be 1/3. All right. Now, what the y stand for? Well, the y, according to our graph, was minutes. So I'm going to put m for minutes. And then G, the x on the bottom of my graph, was gallons. So I'm putting G for gallons. So that's why I switched those into the M and the G. We always start off with that y equals kx format. Next up, number 2. Your friend uses the equation C equals 50p to find the total cost for the number of people, P, entering a local amusement park. Create a table and record the cost of entering the amusement park for several different sized groups of people. Well, remember how we always do that y equals kx format? Well, that C is actually a y value, the cost, and P for people is an x value. So I'm going to make my x the people and the y the cost. And obviously, if no people come, it's going to cost $0. If one person comes, if I pretended that there's a 1 here instead of the p, 50 times 1 is going to be 50. And that's why I have 50 for the cost. And if I said, well, maybe 2 people will come, I pretend there's a 2 here. So 50 times 2 would give me 100, and so on. So it looks like it's about $50 per ticket. So is that cost of admission proportional? Definitely, because it looks like we're dealing with $50 per person for the tickets to get in. What's that unit rate? Well, it's $50 per person, and that's the cost for each person to enter the amusement park. All right, and we sketch a graph to do this. Well, for people, I could have went 1, 2, 3, 4, 5, like over here. I spaced it out though. I went 1, 2, 3, 4, because our x values weren't very high. It was 0 through 5 on our table back there. And the cost, though, I made each mark like $50. So each one of these was 10, 20, 30, 40, 50. Because we end up having a pretty high cost. So as you can see, as I do that, 1 person, and I go up $50. 2 people, $100, and so on. And all my lines do connect. So definitely looks like a proportional relationship when we graph it. Now, what points in the graph must be in the line if two quantities represented are proportional to each other? Well, the line should be able to pass through the origin and make sense. Well, 0 people go in, nobody's going to pay anything, so that makes sense there. And then the unit rate, which is like 50 over 1, so y value is 50, x value is 1, and one person enters, they pay $50. So those 2 points do make sense. What would the point 5, 250 be on the graph? And what does this point represent in the context of the situation? Well, x values were people, so 5 people, and the y values are going to be cost. So if 5 people each paid $50, that total bill is going to be $250. So 5 people, their total bill will be $250. That's what that means. All right, we got just a couple examples we're going to look at. All right, example 1 here, talking about a Jaguar's time and distance. All right, this is over on page 44. And what does the point 5,290 represent in the context of the situation? Well, let's look at this point, 5,290. Well, the x value on my graph is time in seconds, and my y values represents distance in feet. So how many feet per second the Jaguar can actually travel? So that point means the Jaguar runs 290 feet in 5 seconds. What does the point 3174 mean? Well, the Jaguar runs 174 feet in 3 seconds. So is this distance run by the Jaguar proportional to the time? Yeah, it's proportional, and it looks like if we get 58 feet per second. If you keep dividing those out, y's divided by x's, you'd get 58 feet per second. Now write an equation to represent this. Well, we always start off with a y equals kx format for these. And we found out our unit rate, remember 158, or if we took our y value, 58 divided by 1, it gives us 58. It's going to be 58. Now, what does the y stand for? Well, look at your y part of the graph, distance. So I put d for distance. And what was the x value? T, because we're talking about time. So the distance that the Jaguar travels equals 58 times however long of time spent running. All right, and we're going to jump over the top of the next page. Jackie's making a snack mix for a party. She's using cashews and peanuts. The table below shows the relationship of the number of packages of cashews she needs to the number of cans of peanuts she needs to make the mix. Now I labeled this my x column and my y column just to remind me. And if I look at this table, I want to see if it's proportional or not anyways, just from looking at it. So 2 divided by 1 is 2, 4 divided by 2 is 2, 6 divided by 3 is 2, 8 divided by 4 is 2. Looks good. Everything's going to be a 2 there. So it looks like that mixture is going to need 2 cans of peanuts for each 1 pack of cashews. Now, write an equation to represent this. Well, we always start off with our y equals kx format, and then our unit rate was a 2. We found that from determining whether the table is proportional or not. And my y column stood for cans of peanuts, so I'm using P. And then X number was cashews, so use C for cashews. And it says describe the ordered pair in the context of this problem. Well, the 12 would be 12 packages of cashews, and the 24 would stand for 24 cans of the peanuts. So that's what it's referring to. She's mixing 12 packs of cashews, 24 cans of peanuts. Now, before we leave the video here, you'll be looking at information in number 5 to do your practice today on Schoology. So good luck with that, and have a great day.